So as we continue moving forward, solving this will help you in your activity. It'll help you with your problem solving. It'll help you with setting up these word problems as well. Because, again, we refer to this as the entire backbone of what general chemistry is. Yes, there's still some other concepts like that of the gas laws, and gas stoichiometry is just down the road, not too far. But this is encompassing everything that you've learned in the fall semester and then applying it here in the spring semester. So where are some tricky aspects to this problem? Well, first of all, you have to have a reaction. Okay? So for those of you who are maybe tuning in and watching this a little later, this says magnesium nitrate is an aqueous solvent for cleaning metallic surfaces. Okay? If 12 grams of magnesium reacts with 18 grams of silver nitrate, with that comma, we stop right there. What is that telling you? What important information right now?
Magnesium reacts with silver nitrate.
Okay, and then we want to know what is the percent yield if 53 grams of magnesium nitrate is collected, and what is the limiting reactant, because this is what you're doing in your activity next door, something very, very similar. Okay, so how do we set up this chemical equation?
So AgNO3 plus Mg arrow over Mg parentheses NO3 and parentheses 2.
Okay, so we're writing this down as someone in the splash zone,
Yep.
okay, in the front row was saying or stating what our equation actually was. Okay, now you've got your chemical equation. Next thing you need to do is what?
Balance.
Okay, so this is not very difficult to balance. Keep your nitrates together, okay? You've got 2 nitrates here and only 1 over here. Okay? Then when we go over to this side, we just need a 2 there. All right. So now this is where we want to go through our setup process here, okay? What are we starting with silver nitrate? Okay, what are we starting with magnesium? Okay, just by looking at that, 12 is smaller, so that must be our limiting reactant. Could be. Not always true. That's a good way of looking at it. Isn't that kind of like binary code? It's 0, 1, 1, 1, 0, 0, 0, 1, 1. It's either true going this way or false going that way. Isn't that binary code?
That sounds right, yeah.
Okay.
I don't know.
So Mr. Software
Okay.
developer.
So next, this, don't feel bad if this, you're going to get this messed up the first couple, 3, 4, couple times maybe. We don't want to disregard this number either, okay? But it's not implemented in the way that you think, okay? Because we need to solve the percent yield, okay? So what that means then, okay? Let's have happier thoughts like baseball or softball, okay? I get to tell people I'm tired of walking, driving, and looking at ice, okay? Because anywhere you look, there's ice. I can walk on it here, got to walk the dog, walking on ice. People don't shovel their sidewalks. Even if they do, if they don't do a good job, then the sidewalk freezes and that's slippery. And when you're getting old like myself, you slip and fall, that could be catastrophic. Okay, so yeah, hopefully we're not feeling like we're too old. Some days more than others. Okay, yeah, 8 o'clock is bedtime. No, I'm not that old. Okay. So, oh shoot, I know, right?
My grandpa
Okay.
goes to bed at like 7 o'clock.
So if during the course of a baseball or softball game, okay, holy cow, it was 5 at-bats. Okay? So with those 5 at-bats, how many times did this person reach base, not on a strikeout or a walk or an error? Okay? So you can strike out and still be on first, right? You can reach first base by putting the softball or baseball in play and still not get credited for a hit, right? That's called an error, okay? Or if you maybe look at 4 straight softballs or baseballs outside of the strike zone, you take a walk. So does that go, what does a walk do? Does that go to any one of these? Nope. Not the bottom one either. It doesn't count. If you had 3 at-bats and you walk 3 times, you just don't have a batting average for that day or for that game, okay? So a percent yield is same thing as like figuring a batting average, serving percentage. Is there such thing as kill percentage, set percentage, hit percentage, pass percentage? Okay. Has that changed over the last few years? That holy cow, we're keeping record of more stats.
Outfields was high last year.
Okay.
Our passing was fine.
Okay.
Study was good.
What about football? You do the same thing for, holy cow, there's a lot of stats that we're keeping track in football. I don't know. Okay. So what this means is, don't be one of them people, God, I was 6 for 5 that day. Holy cow, you really hit the cover off the ball. That's what, 120%? Is that possible? No, unless there's 2 people batting at the same time, which is not possible. So my point is, you can never have anything over 5 in this case. Same thing would apply here. Just like when you did physical science 3 and 2 years ago, okay? If you had to calculate that, what is that?
No.
Not mass. Mechanical something.
Oh, shoot. I should know it because this was the
Mechanical advantage, okay? Which is work output over work input. You can't have more work output than what you put into the system. So you can't have more hits than what you had at bats, okay? So how does that relate to what it is that we're doing over in the lab, okay? Well, over in the lab, you actually are producing a specific amount of sodium nitrate, no.
silver nitrate and what we put in there.
Oh, I had that equation wrote down somewhere. It was a chromate ion, right?
Yeah.
It wasn't potassium.
It was sodium.
Sodium, okay.
Oh, wait, I wrote
It was sodium, chromium,
chromate and
oxygen, right?
silver nitrate.
So your silver chromate is what you're actually producing, okay? So that precipitate is calculated this, or let me start over. Your percent yield is calculated similar, kind of like this set of at-bats. A percent yield equals your actual yield over a theoretical yield. So what you did over in the lab, you're trying to grab as much powder as you can because you took the water off the top, okay? That's what you actually produced in the lab. That's going to give you a certain amount of grams. On pencil and paper, you're going to say, theoretically, we should have come up with this amount. But you're never going to get a 100% reaction because there's impurities, there might be some water left over in that might throw off your mass just a little bit, okay? my point is you're never going to have your actual yield match your theoretical yield. But theoretical yields is always on pencil and paper, okay? Actual yield is what you actually did with your mind, your hands, over in the lab by dumping a few things together. That's an actual yield. Okay, so we need to change this to either moles or look for a substance over here. So how many of you are moles people only? Well, okay, everyone else has their hand up.
Yes, we are mole people.
Okay? All right. So, if that is the case, which is fine, we'll just start with this one. 18 grams of silver nitrate. Okay? We're going to do what with that? Okay? And for every mole of silver nitrate, it's 107 plus 14 plus 48. And that would give you approximately 170. Okay? 170 grams of silver nitrate. Okay? So when you add all them atomic masses together, here's your molar mass. Moles over grams. Okay? So these are gone. You're in moles of silver nitrate, and that's what we want to be. So what do we do next?
Convert to moles.
Convert it to moles. So 18 divided by 170. Okay? That gives us 0.11. Okay? So 0.11 moles of silver nitrate. So, of course, that's going to be important for one, we wrote it down, but do we want to label this specifically with something? The answer is yes. What would that be? Not yet.
Oh,
You can put that up here. That's how much we actually what? That's how much you actually have. Okay? So this is what you have. Okay? So we're going to do the same thing for our magnesium now. So for every 12 grams of magnesium, okay, we're going to get a mole of magnesium for every 24.330. Okay. This is what I was working on walking down the hall, and someone says, "Do you always carry a calculator?" No, I said, I need to work this out before I get to class, or else it's going to look silly. Don't need any extra help in that. So, all right. So this is probably about what, almost right at 0.5. It's okay. 0.49. 0.49 moles of magnesium. Okay? So we're at 0.49 mole, and that's what we actually have. Okay? So we almost have 50 cents worth of magnesium and only just a little over a dime's worth of silver nitrate. So this is where you play Battleship, right?
Yep.
Where we're going to take this silver nitrate. How much of this is required? So then this retaliates, goes back, and says how much of this is required. So this is one of the things that you can do besides having that attitude. A can-do attitude. Can do is better than cannot.
or can don't.
And can don't. Okay? So we need to see how many moles of magnesium are required, and how are we going to do that? Besides playing your Battleship deal. We're going to change moles of silver nitrate to what? Okay? You got to do something very specific in that step.
Wait.
Okay?
Okay.
And where does the coefficient belong? Okay? So now, when we take 0.11 and we divide that by 2, that gives us 0.06. Okay? We can erase all of that. Okay? 0.06. Now, what we want to write something very specific with this.
Required.
That's how much is required. Okay? So now it takes 6 cents. Okay? How much did we actually have? We had almost 50 cents. Okay? So do we have enough magnesium?
Yes.
Yes, we do. Okay? Well, sometimes we need to make sure, because you might have to do the excess reactant as well. So for every mole of magnesium, you get 2 mole of silver nitrate. Okay? So 0.49 times 2 then gives us 0.98. I guess I shouldn't have to use a calculator for that, but we did anyway. Silver nitrate, and that is REQ. So you almost need $1 worth of silver nitrate. How much did we have? Okay, so what does that tell you about this guy right here? This is your limiting reactant. Do whatever it is you need to do to make sure that you use that number. Okay, now you're one step closer to this. Okay, now we've established what our limiting reactant is. Oh, well, if it is silver nitrate, okay, well, I guess we start with this guy, right? .98, because that's how much is required, correct? No. Why not? We need to start with what we have, because if you don't do that, look at the discrepancy that you're going to have if you start with .98. That's what makes this section so difficult, okay? We're up to 18 minutes. I didn't mean for it to be this long. But how do we finish this then? In other words, we need to find how many X amount of grams. Don't look at this and say, oh, well, we've got it already. That's 53. But that's what the chemist actually produced. On pencil and paper, you need to get from either grams or moles of what you have into the grams of what it is you're looking for. Okay? So we can erase this here. Okay? We'll erase all of that. Okay? And we can get rid of this. And then we can get rid of that. Okay? So now, how are we going to get to this side of the equation now? Say that again. Close. Mole to mole. So for every mole of magnesium nitrate, okay, does this 2 still belong here?
No. No, we already used it.
Yes, it does.
Yes, it does. It still belongs there. Okay? So now, how do we get rid of this mole of magnesium nitrate? For every mole of magnesium nitrate, which is 148. Okay? everything has now canceled. You're in grams of magnesium nitrate, and that's what we're looking for. That's a 53, by the way. So now, when you multiply this out,
You got 100, you got 11, so it should be close to 16, 15.78.
that I'm not sure. Okay, so 0.11 times 148 equals 16.28. Divide that by 2, 8.14. Okay, something's not right here. And that's why.
Okay.
I use the excess reactant
On your baby.
on here. I made a mistake because I was thinking, oh, this is going to work out just fine. I come up with 73. But that's if you use the excess reactant. I needed to use the limiting reactant, so trying to do too many things at once. Okay.
Yeah, you were trying to walk.
Walk and maybe think, and walking and thinking, yeah, that's tough enough. So we'll change this. We'll change this to about, well, you can just do 5.30.
There you go.
Okay? So then this is what you actually produced. So then on pencil and paper, we're supposed to come up with 8.14. So now you've got your percent yield. So, yeah, work is here. I just goofed. It's very easy to make a mistake. Okay? Even the teacher. Yeah. Oh, darn it. We goofed. And right when I looked at that calculator and I looked up at the problem, I go, oh no.
Right. Hold up.
Okay?
Wait a minute.
Something's not right here. Oh, darn it. All right. This, if you're thinking this is easy, and if you're having problems with it, get that out of your head. This is not easy stuff to do. All right? So I think getting up to 23 minutes is long enough. So, so rut row, second row. That's all. It's a third row. All right. So we're going to head over to the lab shortly. And for those of you who are gone, rely on your lab partners here. Are they or are they not in good hands? That's your question. We'll catch up to you next time.